Today I don't feel like doing anything, so I'm just gonna do some sequences. Let me start with some arithmetics, and then I'll jump to geometrics. Oh, and we shouldn't forget the series.
Well, hey guys, that was just a little song to intro our series and sequences that go along with what we're doing. If you want to listen to the rest of that, that's just on YouTube. So 8.3, we're going into the geometric sequences and series. So we've already gone through the arithmetic ones. Those are special ones. Now the next special one is geometric sequences and series. We're going to look at that this one has formulas for writing the rule and also for finding the sum of these finite geometric series. As you can see here, writing rules, there will be a formula for that. It's finding sums, there's a formula for that. Alright, first let's go and do a little cartoon. So this one, so the guy's going into an MRI machine and screams his head off. I tell you, work has gotten to be so much more fun since we hung that rubber spider in there. And they're laughing their heads off. So MRIs are already scary enough. Hopefully you don't ever have to have one. Alright, so let's go on to our first part with the geometric sequences here. Just identifying a geometric sequence is the first thing to do. So on page 228, go and look at that, and you want to write this down for the geometric sequence. For like what the vocabulary is, you'll notice that geometric sequence is the ratio of any term to the previous term is constant. Ratio would be like a fraction. So basically, if you have your second term over your first term, and then your third term over your second term, that would be a number. Basically, what you're doing is you're multiplying or dividing the same number every time. We've written that down. We can go ahead and write this down for this as well. So you can write that down. You're multiplying or divide by the same number. Each time. And that's what a geometric sequence will be. So that's the pattern for a geometric sequence. So that number that we're multiplying would actually be a common ratio. Now this is always in terms of what we are multiplying. Not dividing. So we always have to think about it. If you can see that you're dividing, if the numbers keep getting smaller and you're actually dividing by, let's say, 3, then you want to say, well, you're multiplying by 1/3. You always want to flip that upside down, multiply by reciprocal. So if you know what you're dividing by, then just flip that number upside down. That's what you're multiplying by. You have to always think of it in terms of what you're multiplying, because you need to know what this common ratio is. We had a common difference in the arithmetics, but we have a common ratio in the geometrics. That's just that number that you are multiplying by. So key is there, understand it's in terms of what you're multiplying by, not ever dividing by. Alright, so let's continue on. Okay, so in the extra practice on page 229, 1 through 4, just tell whether the sequence is geometric, explain your reasoning. So we're looking at these sequences just to see, is this a geometric sequence? So remember what that was saying is that we can identify it if we're multiplying by the same number every time. So what would we multiply 4 by to get 12? Well, that would be 3. Well, are we going to do the same thing to get 36? 12 times 3 is 36, yes. 36 times 3, yes. And so you can see, yes, this is a geometric sequence. We're multiplying by 3 every time. But when we look at that, what common ratio is called, you also can do this. This was that definition. So basically the second term is 12, your first term is 4. So if you take 12 and put it over 4 and do that, 12 over 4 is a ratio of the previous over or the term over a previous term. That's going to be 3 there, 12 divided by 4. And then if you do the same thing for the third term over the second term, so 36 over 12, that also gives you a 3. That will always give you what your common ratio is. That's what we're always trying to look for. We always want to see what is our common ratio. That's one way you can always find it, is just do the second one over the first one. That'll give you your common ratio, or the third over the second, will give you the common ratio, and so on. Same thing with the fourth over the third, it'll still give you that. So we say R for common ratio is 3, so it's denoted as R, and that's what it said earlier as well. So you want to put down common ratio is denoted as R. You can put that on your vocabulary. And so this is definitely geometric. On 2, we can look and see, is the pattern, are we multiplying every time? Is there any way to multiply 45 and get 40? Not really. So we get 45, 40, 35. You're noticing there's a pattern here. You're going down by 5 every time. So that's not geometric if you're going down by the same number every time. Instead, we would be subtracting by 5, which really would be an arithmetic sequence on this one. So that would be one of our special ones as well, but it's arithmetic. So we can just put that down. So we know this is not geometric, it would actually be arithmetic. Number 3, now this might be a little harder to see, what do you multiply 1.3 by to get 7.8? And are you going to do that same thing every time? So it might be easier to do it this way, where you're going to take the second term, put it over the first, and so we could do that 7.8 over the 1.3. So basically that's like 78 divided by 13. And we can do that on a calculator, 78 divided by 13. And that equals 6. So right there, that's 6. And we're going to get the same thing as if we do the third one over the second one. So if I do the 46.8 over the 7.8, again, that's going to be like, we could divide this 468 over 78, or I can just put the decimal in there, it doesn't matter. So I'll put just 468 divided by 78. Is that 6 as well? Yes, it is. It's 6. So it continues to be the same thing. We could do the same thing each one here. We could do the same one, and it will continue to be 6. I'll let you know that. But yes, this has got a common ratio, so since it does have that common ratio, then we know it's geometric. We are multiplying by 6 every time. Number 4, this one also might be kind of harder to see. What are we multiplying 3 over 2 by to get the negative 3/4? Well, first thing we'd have to be multiplying by would be a negative. Are we changing the signs every time? Yes, they're all alternating, positive, negative, positive, negative. So that means our common ratio could be negative. What are we going to multiply the top by? Well, we're not going to multiply the top by anything, you might think. It's still 3, but you really do multiply the top by a 1. So the top could be a 1. What are we going to multiply the bottom by every time? Are we, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Looks like we keep multiplying by 2. So it's like doing this. Negative 1/2 multiplying this 3 over 2 gives me my negative 3/4. And then if I multiply that by a negative 1/2, that will give me a positive 3/8. So this is got a common ratio. The common ratio is a negative 1/2. That's what we're multiplying by every time. So yes, this is a geometric sequence then. All right, let's continue on with our notes. And back on page 228, this core concept is now what we're going to use as a rule for writing these geometric sequences. So here is the formula, and this is something you want to highlight. This is what we use here on this one as a formula to write the rule. So here's an example of that, and it's written like this, where basically the only thing you're going to be putting in is you're going to be putting in the a of 1. So that would be your first term. So first term is a of 1, and you also need to know your common ratio r. So there's those two things, just those two things you need to know again, first term and what the common ratio is. So if this one says that the first term is 2, then 2 goes here, and the common ratio is 3, so 3 goes here. Now notice how they did that. They put 3 in a parenthesis because the common ratio is raised to the exponent. So you have to do the exponent first, then multiply by the first term. So that's where they're going to put this here. They're going to put this in a parenthesis, common ratios going in a parenthesis, raised to the exponent, n minus 1. Now we saw n minus 1 on the previous formula. It just wasn't in the exponent spot. It was in a parenthesis where we had to distribute into it. Well, now n minus 1 is up here as an exponent. And so we would do that first, then we could multiply by 2 if we were going to figure something out. So if we knew what n was, like if n was 3, we would do that first here, and then raise the 3 to that power, and then multiply by 2. All right, so let's do a couple of those. Okay, 5 through 8 says write the rule for the nth term of the sequence, then find a of 6. That would be the 6th term. So starting with just writing the rule, we're going to need to know again that formula, so we got to plug it into the formula, so keep that there in your head. or in your mind there about what the formula is. And then we're going to say what is our first term and what is our common ratio is the two things we need to know. So our first term on this one is just obviously 6. What's the common ratio? What are we multiplying by every time? So 6 times what is 18? That would obviously be 3. And then 18 times 3 is 54. So 3 is our common ratio. So we're going to plug it in. We're going to say a of n equals, and then your first term 6. 3 is going to go in a parenthesis, and then your exponent's always n minus 1. So that's what it looked like right there. So it starts your first term, and then the common ratio goes in a parenthesis, and then the n minus 1 is the exponent. That's all there is to it. Now, if we're finding the sixth term, you could just use a calculator and pretty quickly generate the sixth one. If we know this is our fourth one, we can just multiply this by 6 and then multiply by 6 again to get that. But another way we can do it, especially if you need to find something even larger, is plug it into here. So we could plug 6 into here. So 6 minus 1, we can say, okay, our sixth term, a of 6 would be our sixth term. That's going to be 6 times 3 to the 5 exponent, because 6 minus 1 would be 5. So we can do that. So we can say 3 to the 5th. What's 3 to the 5th? Well, that's 243, and now 243 times 6, that's going to give us our number of 1458. Now that might be a little bit harder. You could have also done it this way. I'll just show you again. So if we know 162 is our fourth term, we could say, okay, times 3. That's giving us 486. That would be our fifth term, and then times by 3 again, and that's going to give us our 1458. That's the same thing we got there. So again, we can do it on the calculator this way, or you could do it this way. This way is helpful if you have to go to like maybe the 10th term or the 15th term, something much larger or higher. But again, you could, still, if we're just doing the sixth one, we can do it this way. Number 6, so our first term obviously right there, 3. That's easy to spot. The common ratio, what would the r be? What are we multiplying 3 by to get a negative 6? Well, we need to multiply by a negative, and it needs to be negative 2. So negative 2 is the common ratio. So again, we're going to plug it in. So just like this, a of n, we're going to start with the first term is our positive 3 here. Negative 2 is going to be the one in the parenthesis. So it's going to look like that. 3 times negative 2 in the parenthesis, n minus 1 is the exponents. That's our rule. For this one, it's an exponential rule now. Remember, geometric ones are exponential. They're exponential functions. That's something you may want to write back on your vocabulary, is to make sure you note that a geometric is an exponential function. If we were to plot these points, they're all going to graph into a kind of a Superman ride graph, because the exponent here has the variable. So now if we want the sixth term, I'm going to do it again the same way I did it over there. We could keep multiplying by negative 2, and that's not hard to do. But if we want to say the sixth term, it's going to be, again, the fifth power here. Negative 2 to the fifth power, that's going to be negative 32. So 3 times negative 32 would give us our number here of negative 96. It's the same thing as if we said negative 24 times negative 2 is positive 48, and then 48 times negative 2 is also negative 96. Okay, number 7, we can see our first term right there is 1, so there's our a of 1. What is our common ratio, though? What are we multiplying 1 by to get 5 over 2? Well, that would have to be 5 over 2. Are we multiplying that again to get 25 over 4? And yes, we are. 5 times 5 is 25, and 2 times 2 is 4. So 5 over 2 is the common ratio. So we'll put that in now. So our a of 1 is 1. If our a of 1 is 1, we actually don't need to write it. It doesn't make any sense to write 1 here. We can just put the 5 over 2 to this exponent. That's all we really need then. So that's all we need. So a of n is equal to just the 5 over 2 to the n minus 1. We assume there's a 1 in front of this. Okay, so when this a of 1 is a 1, we actually don't need to write the 1. You can if you want, but you don't need it. And then if we wanted to figure out what the next one is, you can keep multiplying the top by 5, the bottom by 2 more times to get that. I'll do it this way though. So a of 6 we're going to see as 5 over 2 to the 5th power. So we see just what is 5 to the 5th power and 2 to the 5th power. That's all we need to do. So 5 to the 5th power is 3125, and 2 to the 5th is 32. So there it is. You can do that on a calculator as well. Either way, you're going to have to use the calculator to calculate this probably. So whether you want to do it just by keep multiplying 2 more times in this one to get that number, or to use the exponent button on your calculator. So 5 to the 5th is an exponent button. 2 to the 5th, hopefully you might be getting familiar with now, is 32. Number 8. So our obviously first term there you could see is negative 2.4. What's our common ratio? What are we multiplying by every time? Well, they're all negative, so we'll be multiplying by a positive. R will be positive. So 2.4 times what is going to give us 16.8. So that might be a little more challenging to do. So here's what you could do on a calculator. If you're not sure what the common ratio is, do it like we did before. Take the second term, divide it by the first. I'm just going to do it as positive over here. So I'm going to just say 16.8 divided by 2.4. And that gives me 7. So there it is. It's 7. So our common ratio is going to be 7 then on this one. So that's what I did there. I just showed you we can take the second term and divide it by the first term, and that gives us 7. And now we plug it in, where 7 is going to be in the parenthesis, negative 2.4 is going to be in front of that parenthesis. So there it is. A of n is equal to negative 2.4, 7's in the parenthesis, n minus 1 is your exponent. Sixth term, we could say 7 to the 5th power for that sixth term, and figure out, well, what is 7 to the 5th power? We would use an exponent button for that. We can use a calculator in the one we have in class, or even just the one on the computer, and then multiply it by negative 2.4. So 7 to the 5th power is 16,807, and then multiply that times negative 2.4, and that gives you our sixth term, which is negative. It will be a negative. It should be negative because they're all going to be negative. So you got negative 40,336.8. So we also could have done it this way, taken this number, multiplied it by 7, and then what we got there, multiply it by 7 one more time to get this number. Alright, so here's our joke of the day. One farmer proudly said to another, "I had a hen that could count her own eggs. She was a math-ma-chicken." Of course, that's got to be a good math joke right there. A little math-ma-chicken. Don't call me a math-ma-chicken. Alright, problem number 9 on page 230. Now at the very top, it says write a rule for the nth term of this sequence, where basically a of 8, our 8th term, is 384, and the common ratio, r, there is 2. So you're multiplying by 2 every time. And it says then graph the first 6 terms of the sequence. So we would need to find those first 6 terms and then plot them on a graph over here. So again, we need to know our formula. So again, that same formula. Let's go ahead and write this down here for the formula. A of n equals a of 1 times r to the n minus 1. And so we need to, again, know those two things. We need to know what's the first term, what's the common ratio. We know the common ratio is 2. That's going to go right here, but we don't know is our first term. So we're going to plug everything in that we do know. We do know the 8th term is 384. So a of n would be here. So basically n in this one, this is our n, right? A of n is a of 8. 8 is the n. So 8's going to go here. This is going to be a of 8, which is actually 364 going over here. And then we can plug in 2 for r. So let's plug everything in, and we don't know the a of 1, so it's the only thing that's going to stay as a variable there. So now we got 8 minus 1 is a 7. So now our exponent is 7, and we plug 8 in for n. And so we want to figure out, okay, what's the 2 to the 7th power? And so you keep multiplying 2 times 2 times 2 every time. That will give us 128. So 2 to the 7th power is 128. To solve now for a of 1, we just have to divide by 128. So divide both sides by 128. 384 divided by 128. You can do that on the calculator to check this. Our a of 1 is 3. So if our a of 1 is 3, now we can write the rule. We're going to just plug in r as 2 and a of 1 is 3. So here's our rule. A of n equals 3, first term, r in the parenthesis, and then n minus 1. So there's our rule, just like we wrote before on the last 4 problems. But this one now wants us to go ahead and find the first 6 terms and plot them on the graph. Well, we now know our first term has got to be 3. So Let's go ahead and make a table of values. So a little t-chart, kind of like x and y, but we're going to say n and a of n. And this is our sequence notation. N is like the x, a of n is like the y. What numbers do we need to plug in for n? Well, it says the first 6 terms, so that's 1 through 6. So we're just going to plug in 1 through 6 for n. Now we know our first term already. We found it. It's 3. So we know the first term is 3, and our common ratio is 2, so that's easy to do. Just keep multiplying by 2 every time. So 3 times 2 is going to give us 6 for the second one. 6 times 2 is 12 for the third one. 12 times 2 is 24 for the fourth one. 24 times 2, 48. 48 times 2, 96 for that sixth one. So now we have all these ordered pairs. 1, 3, 2, 6, 3, 12, and so on. Let's go ahead and draw our axes over here. I'm just going to do it like an L graph. So we're going to have our A of n axis, that's like our y-axis there, the n axis over here, which is like our x-axis. And let's go ahead and number these. So we're going to go for the n, we're going to just number them 1, 2, 3, 4, 5, 6. So that's all we do there. Each one is worth 1 down here. But for the A of n axis up here, this axis, we need to get all the way up to 96. So I'm going to make this, every one is worth 10. So 10, 20, 30, 40, and so on. So 10 here, 50 would be here, 100's all the way at the top now. So each one of these is going to be worth 10 going up, but each one's going to be worth 1 going across. And so when I go to 1, 3, let's go ahead and plot that one. 1, 3, it's going to be right down in here. So 1, we're going to go up just a little bit for 3, 2, 6, still not quite to 10. Now remember what this should look like as we graph this. It's an exponential. It should not be a straight line. It should be a curve going up, an exponential curve like the Superman ride graph. 3, 12, well now we're a little bit above 10 now. And then 4 and 24, now we're a little bit above the 20, almost halfway there, in between 20 and 30. And then 5 and 48, we're almost up at 50, just a little bit below the 50 there at 5. And then 6, 96. And so it's going to be all the way up here past 90, about halfway in, a little bit above halfway. And as you can see, if I was to connect these dots together, it makes like a Superman ride graph going up. Okay, that's our exponential curve. Alright, so here are our problems for 10 and 11. It wants us to write the rule for the nth term of the sequence. So let's keep that rule there in front of us. The A of n equals the A of 1 times the r to that n minus 1 power. That's what we keep doing. We've got to know what that first term is and what that common ratio is. But on this one, they don't give us either one of those. They give us that the third term is 54, the sixth term is this 1458. Same thing over here. They give us 2 separate terms, not the first one, not even the common ratio. So what we need to do on this one is, again, we're going to use a system of equations. So we're going to have to write out 2 equations. We're going to basically take each one of these and plug them in to our kind of formula here, so that we have 2 formulas kind of next to each other, and we're going to have to use substitution. So we'll be using our substitution method of system of equations for this one. On the last one, we could have used the elimination. That was in the arithmetic one. But for this one here, where they're the geometric ones, we're going to need to use the substitution method. So first of all, let's start by making those equations. So our first one, A of 3 is 54, so n is the 3. So n is 3 here, and this is A of 3 then, so that's going to be the 54 over here. So, oops, that's right, I'm going to write this one out. So here we're going to do it, we're going to say 54 now. So 54 is equal to A of 1, because we don't know that. We don't know the r, but now we're going to need an exponent for the r, which is going to be, this one, 3 is n, so 3 minus 1 is 2, so it's going to be r squared. Okay, so we're going to need to get another equation. Let's go ahead and do a different color. So our other equation for this one here will be n is 6. So this is our A of 6, which would be this, so it's going to be 1458 is equal to the A of 1 and the r. Now I need the exponent for the r, which is going to be 6 minus 1, which will be 5. Okay, so now in order to use the substitution method, I need to have solved for something here. And we need to solve for the A of 1. We're not going to want to solve for r because it has an exponent. So we're going to go ahead and solve this one here for A of 1. I'll bring it kind of over here. So when I do that, all I need to do is just divide by the r squared to get a of 1 by itself. So an a of 1 here is going to equal 54 being divided by r squared. So that now I can use it to substitute back into right here. I'm going to take this right here and substitute it for my a of 1 right there. So let's go ahead and do that. So it's going to say 1458 is equal to, instead of a of 1, I'm going to have this going in, 54 over r squared, and then times an r to the 5th. So what I can do now is I can cross cancel these r's. So let's go ahead and do that. Let's cross cancel. R squared will completely cross out, and then we're going to take 2 away from 5, which will make this a 3. So now it's r to the 3rd. So 54 times r to the 3rd. So that's what we have now. So we're going to say 1458 is equal to 54 r to the 3rd power. So now let's get the r to the 3rd power by itself by dividing by 54. And so when I divide that, let's go use our calculator just to figure that out real quick. 1458 divided by 54. And that's going to give us a number of 27. So this will be 27 on this side, equal to, because these canceled out there, r to the 3rd. Now to get rid of the exponent of 3, we need to undo that with a cube root. So let's do a cube root now. So I'm going to take the cube root of this each side. So that's going to free my r, so I'll now find out what the r is. Cube root of 27 is 3. We should know that one. So now I get 3 for r. Now that I have that, what I can do is I can plug that back into my r up here, so I can figure out what the a of 1 is. So a of 1 is 54, and it's going to be 3 squared down here. So that's going to end up being, for a of 1, 54 divided by 9. And 54 divided by 9 is 6. So the a of 1 equals 6. So now we can write our equation, our final answer here for this. So our final answer is the equation. We're just going to plug in the two things like we did before. So a of n is equal to 6 for the first term, and then 3 is the r, so that goes in the parenthesis, n minus 1 exponent. So there's our answer now, which is the rule. They want us to write a rule. There's our rule. All right, so number 11, same idea. Let's go ahead and try this one. Okay, so we're going to start off with just taking this first one. The second term is negative 2. So let's plug that in. So for the a of n, that's a negative 2. So negative 2 equals a of 1 times r, and the exponent is going to have to be 2 minus 1, which will be just 1. Now I don't need to put 1. I can just leave it as r there then. Let's try the next one over here. Our fifth term is a 2 over 125. So it starts off with a 2. I'll do a different color. So 2 over 125 is equal to a of 1 times r, and this is the fifth, or 5 is the n, so 5 minus 1 is going to give us 4 for the exponent on this one. And again, let's go ahead and I got to solve. Let's take this one. It's definitely a lot easier, and convert that to where we can see what a of 1 would be. So I'm just going to, again, divide by r. So the a of 1 is going to be the negative 2 being divided or over the r. And now I can take this here and substitute it down over here for the a of 1, right in that spot. So it's going to start off with the 2 over 125 is equal to, instead of a of 1, we're going to replace it with this. So negative 2 over r times r to the 4th. And so now we can cross cancel r's again. So this r cancels completely. I'm going to take 1 away from 4, which leaves me with 3 left. So we're going to see the 2 over 125 is equal to negative 2 now times r to the 3rd. So negative 2 r to the 3rd. I need to get rid of my negative 2. Since I already have a fraction here, it might be easier to multiply by the reciprocal of this. So that would be a negative 1/2. Okay, I still want to keep it negative because negative times negative will keep it positive here, which is what I need. and the 2's will cancel out. So that leaves me with my r to the third by itself on this side. I'm going to multiply this one also by a negative 1/2. So that makes this fraction negative, and 1 times 2 is 2, is still on the top. 2 times 125 is 250 on the bottom. So we have now 250. We may want to simplify that. In fact, I will. We can simplify that to 1 over 125. Really, actually, what we could have done is we could have cross-canceled the 2's. I should have done that instead, really. So let's go ahead and I'm going to erase that there. And just see it. We can cross-cancel our 2's here. Those 2's can cross out. So now I have a 1 over 125. We definitely want the simplest form of that fraction here. And now we're going to take the cube root again of both sides. So we'll take our cube root of this. That frees the r completely there. So now r on this side will equal, we can figure out what r is, the cube root of a negative 125. It's okay that it's a negative. It just means that our r is going to be negative. The cube root of each numerator and denominator. The cube root of 1 is 1. The cube root of 125 is 5. So there's our r, a negative 1/5. Let's go ahead and plug that back in for r up here. So we're going to see our a of 1 is equal to negative 2 over a negative 1/5. And so we want to realize that it's a division problem. It's like saying negative 2 divided by negative 1/5. And here we want to multiply by the reciprocal. So that would then end up being negative 2 times the reciprocal of this is negative 5. So that leaves us with an a of 1 equal to negative 2 times negative 5 is positive 10. So a of 1 is 10. We can now write the rule starting with a of n. So a of n equals, the first term is 10, so it's going to be 10. R is going to be in the parenthesis. That's the negative 1/5. And it's to the n minus 1 exponent. And so that will be our answer. We wrote the rule for this one. All right, so now let's go on to now looking at how to find a sum of a series. Okay, so back on page 228, we see this other core concept, the sum of a finite geometric series. Here's a formula for finding this, and it has to be finite. We cannot find we will look at, actually the next one we'll see an infinite series of how we'll see an infinite series, but basically if the numbers keep getting bigger, there's no way to find the sum of that series. So this one, it has to be finite in this formula. This is for a finite series where you have only a certain number of terms in this series. So the sum, s of n, is equal to a of 1. So there's your first term again. 1 minus r to the n. So there's your common ratio again. N is just the how many terms you have. How many terms are you actually going to be finding the sum of? Is it just the first 10 terms, the first 20 terms, whatever that is, that's the number going there. So then we have 1 minus r. So we already know that this here means the first term, and r means the common ratio. That's what we've been looking at. But again, this n, maybe you might want to write down again, what does n stand for here in this one? This n here is standing for the number of terms to be added together. And so basically when that is in sigma notation, it's usually going to be the number up on top here. Usually your n number is going to be what's on top typically. So that's what's going on in this one. Okay, let's just watch this one here. For the finding the sum, we can go ahead and watch this one. You can write this one down there in your notes on that right below this, in fact. So right in the notes section right here, underneath this one, let's go ahead and write down this right here. Just go ahead and copy it down. Just the sigma notation, 10 on the top, k equals 1 on the bottom. Here's our rule out here. 4, that's your first term. 3, that's your common ratio. And then k minus 1. So we know what our common ratio is. We know what our first term is just from the rule right here. So we have to know our formula. So remember our formula here. So we're going to find the sum. We know our first term is 4. We know that's right there. It's 4. We are common ratios. Those are the first two things to identify. So here's our formula. Now 10, like I said, is the ends. They're going to put 10 in here. This is S of 10, the first 10 terms. That's the number on top. Your A of 1, that's going to be the 4. 4 is going to go out here. 3 is going to be going inside here in both places. So you can now just kind of copy this down here underneath copying this. So S of 10 equals, you can start just plugging it in. Actually, you can just start plugging this in right here. So you can say S of 10 equals this part here where all the numbers go in. So 4, which is your first term, then 1 minus 3, which is the R to the 10th power, 1 minus 3 on the bottom. So we got to do, what is 3 to the 10th power there? You have to figure out what that number is, and know that this gives you a whole big number at the end, but basically you're going to do what is 3 to the 10th? And then 1 minus that number, this is negative 2 on the bottom, so you'll divide that by negative 2 and then times it by 4. So all of that's being done there to get this big number of 118,096. So you just got to do order operations at this point, and that's what they are assuming you know how to do real quick. But just do exponent first here, then 1 minus that, and this will be negative 2. So you can divide this by negative 2 and then multiply it by 4. Okay, so problem 12 on page 230. Let's take a look at this one. And we're going to notice this one's a little bit different. What you're noticing on this one that's a little different is that the number on the bottom is not 1, it's 0. So this is going to do something slightly a little different. So we're still going to need to find out, okay, let's go ahead and remember what our formula is for finding the sum. So that's this right here. The S of n is equal to the first term, and then this big fraction here, 1 minus r to the n over 1 minus r. And so we do need to know what our A of 1 is, which you can see is right here, 3. So that's our A of 1. And we also need to know what the r is. That's right here in the parenthesis. That's your common ratio. 3 over 2 is r. Okay, so that's what we need to know for our formula. The n typically is going to be this number here, 10, and that will still be our n. This will still be n right here. But the problem is that it wants you to start this one with 0. So they actually want you to find the sum from 0, plugging 0 in, all the way to plugging 10 in. So it's 0, 1, 2, 3, 4, 5, 6, and so on. So your n is this number always up here, 10. But that means that there's not just 10 numbers. So there's actually one extra number, this 0 term, and we need to find out what that term is first. So what is the number if your I is 0? If you plug in 0 here for I, what number do you actually get? So we need to say, what is A of 0? That's what's over here. So A of 0 is going to be the 3 times the 3 over 2 to 0 minus 1. Well, 0 minus 1 is a negative 1. So that means we're going to have to basically flip this upside down. That'll become a 2/3. So it'll be 3 times 2/3, and there we can cross cancel the 3's, which is just leaving me 2. So A of 0 is 2. So that's what we need to add. So this is kind of an extra number that we're going to need to add to this, because this is only going to account for 1 to 10. So that's the 10 numbers, because from 1 to 10 is 10 numbers. This is only going to account for the sum of the first 10 numbers. So since we have 11 numbers really to add together, because they wanted us to start with 0, we have to include, once we're done, adding 2 to our sum. So we're going to say 2 plus this S of 10. So we're going to figure out now the S of 10 using the formula, and then once we know that, we can just add 2 to it to find the actual final answer that they want us to find on this one. So that's why it's just a tiny little bit different. But we're still doing the same thing as far as finding the formula here with the S of 10. So let's plug everything in. So starting off with, we're going to say 2 plus. I'm just going to keep saying the 2 plus so I don't forget to add 2 to the end. So 2 plus, and then it's going to be 3 for the A of 1, and then parenthesis 1 big fraction, 1 minus up on top, and then it's R, which R is at 3 over 2, where I'm going to change it to 1.5. 3 divided by 2 is 1.5. I think it might be easier to write a decimal there. And it's going to be 10 is my n here, so it's going to be to the 10th power. And then at the bottom, it's going to be a 1 minus 1.5 again. That's the r again. So now I need to figure out, okay, what is 1.5 to the 10th power? Okay, so using the calculator, we can just do that real quick. We can say 1.5, and then my exponent button would be right here, y to the x. I'm going to raise it up to the 10th power. That will equal 57.66 and so on. So now we want to basically say, okay, take 1 away from that, or make that a negative. That really is going to be a negative number, so I'm going to make that negative, and then add a positive 1 to it. So plus 1 to that, and it's going to say negative 56.7. Let's just round it up to 1 decimal place for this one. So we're going to start by saying 2 plus again, 3, and then the parenthesis on top, it's now going to be negative 56.7. That's what we found on the calculator screen here. Negative 56.7, we rounded up 1. And then on the bottom, 1 minus a 1.5. So that's going to be taking 1 away from a negative 1.5, which means it's just a negative 0.5 at the bottom. So now we need to divide this number by negative 0.5. So we can do that on the calculator. So I'm going to say divided by 0.5, and let's go ahead and make that negative, and equals a positive 113.3. So now let's put it down here. Again, starting off with 2 again, so don't forget I got stuff to add 2 to the end of this. So 2 plus 3 times that 113 point, I put 0.4, I probably should have put 0.3, but that's okay. Yeah, 0.3, 0.4, we'll get a close enough answer there. So it should have been 0.3, but that's all right. 3 times that, so let's go ahead and just multiply this by 3. So times 3 gives me 339.99. That's nearly 400 there. Did I do that right? That doesn't seem like I did it right. Oh yeah, I guess so. So let's see. What do I have for that? So 2 plus 340. I think I did do that wrong. Let me go back here. What did I do? So we had 113.3. I'll just even use 0.3 times 3. I must have hit something button wrong there. Times 3. There it is. Yeah, 339.9. Oh, I did it right. I just thought it was 99. So yeah, there it is. Like, it's about 340. And so when I did this one, it came out to be 340.2, in fact. So it's really close to 340. And so it's going to be 2 plus that now. So if we just add 2 to that, that's about 342, approximately 342. And so that's what we'll say for our final answer, 342.2, or somewhere close to that. You know, 342.1 or even 0.0 would be fine as well. All right, so that concludes this 8.3. So you want to go on to doing the 8.3 assignment, and I'll see you guys in class.